Hi everyone. We will continue today section 3 chapter 3, which is about Newton's second and third laws. First, in the previous section we talked about the Newton's first law and its consequences, and we know that Newton's first law indicates that in the absence of a net external force acting on the object is equal to zero. So if net force acting on the object is equal to zero, so there are two possibilities. One of them is if the object is initially at rest, it will continue staying at rest, or if the initial object is in motion, it will continue moving with constant velocity. These are two possibilities if the net force acting on the object is equal to zero. But what if the net force acting on the object is not equal to zero? Let's remember the first one. So if the net force acting on the object is equal to zero, object will stay at rest. If it is initially at rest, it will move with constant velocity if it is initially in motion. In both cases, acceleration will be equal to zero. If the net external force acting on the object is not equal to zero, so object will accelerate. Newton's second law talks about this. So Newton's second law states that if a net external force, net external force acts on the object gains acceleration. Assume that there are two identical basketball. This is the first basketball, this is the second one. If you apply a weaker push to the first one and a stronger push to the second one, you can easily predict that the second one will move faster than the first one, because a stronger push will cause a big increase in speed, while a weaker push causes a small increase in speed. And while there's a stronger push, you are going to apply a greater force. That greater force causes a greater acceleration. So the first relationship between the object and the force is this: acceleration of the object is directly proportional to net force acting on the object. Greater net force acting on the object will result a greater acceleration. Now assume that there are two different balls. One of them is the bowling ball, second one is basketball. This time you are going to apply equal pushes on these balls. Of course, the one which is a greater inertia, because remember, inertia was the resistance of an object to a force. When you try to push these objects, the one which is a greater inertia, which is the greater mass, the bowling ball, will resist this force. That's why its acceleration will be small. Then we are going to say that because inertia of the basketball is smaller, its resistance to the net force will be smaller. Because inertia of the bowling ball is greater, its resistance to the net force will be greater. So when equal forces are exerted, the object with a smaller mass accelerates faster. Then we can say that acceleration of an object is inversely proportional to the mass of the object. And we will represent this by A is proportional to 1 over mass. As mass increases, acceleration decreases. But relation between net force and acceleration is directly proportional. As net force increases, acceleration increases. Then if we combine these two, we will get the equation which calculates the acceleration of an object, which is net force divided by mass of the object. Then if you cross product this, you will get that F net is equal to mass times acceleration. You can rewrite this equation in an alternative form because the net external force, which means it is the sum of vectors, sum of all forces acting on the object, must be equal to mass of the object multiplied by acceleration of the object. A question. The net force on a golf cart is 390 Newton north. If the cart has a total mass of 270 kilogram, what are the magnitude and direction of the cart's acceleration? So mass is given in the question as 270. We recorded in here. Force, net external force is given as 390 and directions to the north. Calculate acceleration of the object. We know directions. North is going to be up to the page, south will be down to the page, east will be to the right, west will be to the right, to the left. And because the force is net force is in direction of the north, I'm going to draw an object and I'm going to locate this net force on the object, apply from its center of mass, so upward direction. And then I'm going to apply the Newton's second law of motion for this object. We know that sum of the force or net force acting on the object is equal to mass times acceleration. Because the mass is a scalar quantity, these two vectors will be always in the same direction. There is no exception. So our net force acting on the object and acceleration of the object will be always in the same direction. Then I can say that this object must accelerate towards north. And let's calculate the magnitude, because we know that magnitude of the net force is equal to mass and the magnitude of the acceleration. We are going to calculate the acceleration. We should divide it by mass, simplify mass. So acceleration will be F net divided by M. F net is given as 390, M is given as 270. When we divide these two numbers, we will get the result as 1.44 meter per second squared. Then I can say that acceleration of this card is going to be in the north and magnitude is 1.44 meter per second squared. Now we are going to solve some sectional questions. And question number 4, the forces acting on a sailboat are 390 Newton north and 180 Newton east. If the boat, including the crew, has a mass of 270 kg, what are the magnitude and direction of the boat's acceleration? Let's record first the given of the problem. So what is given in the problem? Given is, mass is given, mass of the boat is given, 270 kg. And there are two forces. So say that F1 is this force, which is 300 Newton to the north. F2 is the second force, which is equal to 180 Newton east. So let's record them. F1 is 390 Newton, which is north, in the north. F2 is equal to 180 Newton to the east. So what are the magnitude and direction of the boat's acceleration? For calculating the boat's acceleration, question is A. We should first find the net force acting on the boat. So directions are given like this: north, south, east, and west. And according to these directions, so let's draw the sailboat in here as a model. Let's draw a model. It's a square. The square is representing the sailboat. So we are going to draw the forces from center of gravity. One force is in north, so I am going to draw first force towards north, F1, which is equal to 390 newtons. And second force is east, towards east, so I will draw F2 due east, 180 newton. So net force, I'm going to use vector addition. So we are going to add them in vectors, and I can calculate this resultant force, F net external force acting on the boat. So by using Pythagorean, we can calculate it. According to Pythagorean theorem, we know that F net must be equal to, inside the root, F1 squared plus F2 squared square root. So let's get F net. F net is going to be root F1 is 390 squared plus F2 is 180 squared. So get its square root. Let's use the calculator for getting the answer. So root of bracket 390 squared plus 180 squared, close the bracket, answer equals 429, almost 430. So F net force acting on the boat is equal to 430 newtons. Now we got the net force. We are going to calculate the direction and magnitude of the acceleration. First, we know that net force and result acceleration are always in the same direction, because we know that F net is equal to m times acceleration. So that's why this object will accelerate in direction of northeast, east of north. And magnitude, we are going to use again Newton's second law for calculating the magnitude of the acceleration. Net force acting on the object must be equal to mass times acceleration. So divide by m for calculating the acceleration. Acceleration is equal to net force divided by object acting on the net force acting on the object divided by mass of the object. So net force is 430, mass is equal to 270. Let's divide this. Result is equal to almost 1.6 meter per second squared. So the acceleration of the boat will be in the northeast and east of north, and with a magnitude of 1.6 meter per second squared.